All right, everyone, welcome back and welcome to our first session. Main stage sessions here at TWiMLCon are pre-recorded. We've got a couple of options for engaging around sessions. The chat and Q&A panels to the right of the session stream. Q&A panels are great because you can upvote questions as we noted in the previous session. As was noted in the chat in the previous session. There will be a live Q&A with the presenters afterwards, so please do be sure to ask any questions for the speaker in the Q&A panel and keep an eye on it to upvote the questions of other participants. For general comments or to ask general questions of the room, of course, you can use the chat panel. Once again, apologies for the technical issues earlier. Without further ado, let's hear from the let's hear from our speakers at from Spotify.
It'll be quick, so if you have any questions about anything that we're going to talk about, please enter them in the chat box, and we'll get to them after the end of our presentation. But first, I want to talk to you about why we have a machine learning platform in the first place. So here's the scenario. Flashback to 2017. We have these three ML engineers that joined Spotify, Mira, Gustav, and Lou. They have great mathematical and statistical minds and a super promising skill set. We throw them on the team that builds Discover Weekly. They spend the first 3 months onboarding and learning how Discover Weekly works. It was handcrafted by an employee that unfortunately no longer works at Spotify at that time. So it's not the easiest task to get up to speed. Nevertheless, they do, and they start to understand how it works and operates. Now they're fully on board. They spend over 50% of their time fighting big table issues and index management because those are the technical challenges that are causing the team the most maintenance burden. They spend 25% of their time understanding how to measure the performance of Discover Weekly so that they can improve it. If they're lucky, they have a few hours a week trying to introduce new techniques that might work well in underperforming markets or in improving the algorithm. So they have less than 25% of their time improving the product, less than 25% of the time working on the fun stuff that they joined Spotify to do. So what happens? They leave Spotify or transferred to a team that's just starting on a brand new problem and has no technical debt. A new team member comes into the Discover Weekly team, and we'll start over the process, this time with one extra layer of code in between. So this is what we were seeing a few years ago, and it's not a great experience. It's not good because we had some really great ML engineers that just weren't doing machine learning. They were spending all their time on back end and data bits and data toil, keeping their services alive. And in fact, we actually had to raise our hiring bar to ensure our ML engineers had those necessary backend and data skills in addition to the machine learning know-how. And of course, all of us here know why. It's because building ML systems isn't just about modeling. There's a lot of different factors in place. And of course, because this is a machine learning platform talk, I must include the mandatory and incredibly influential diagram from the Hidden Technical Debt Machine Learning Systems paper. But we really do want the machine learning engineering job to be about building models. We want to extract away as much of that complexity as possible so that the engineers are more productive in focusing on all the modeling and experimentation funness that leads to innovation and a better product experience. That's why we exist, and that's what machine learning platforms are for. And for the next 20 or so minutes, we're going to talk to you about what we built at Spotify to make it funner to be an ML engineer and to build reliable, consistent, and impactful products without causing machine learning engineers to rage quit. But to back up a bit first, I'm going to throw out some numbers just to give you an idea of the scale we're working with at Spotify. So Spotify was launched in 2008. We have over 300 million users now in over 90 different countries. Those users created over 4 billion playlists from a catalog of 60 plus million tracks and nearly 2 million podcasts. And this is a preview of how our machine learning platform was used in 2020. So now we have more than 50 machine learning teams around Spotify using ML and using our platform. And those teams have trained over 30,000 models in 2020 using our tools. They've ramped up to about 300,000 predictions per second using our model serving framework. And we've seen ML productivity, as measured by model iterations per week, increase over 700% in 2020 alone due to our platform enhancements. And what are some of those teams doing? Well, we use machine learning in a variety of ways in the app. The most obvious one is that we personalize the app experience for you. We use it to improve the recommendations that you receive. We use machine learning to improve onboarding, the quality of our messaging that we send out, improve our ability to succeed in new markets that we launch, just to name a few. And you might be wondering how we got to where we are. Well, Spotify has actually had machine learning products since almost the very beginning. Our earliest efforts were usually custom-built code running on a Hadoop cluster. And in the picture here, you actually see one of our early Hadoop clusters, which was located in the corner of our game room in our Stockholm, Sweden headquarters. You also see a really happy engineer there. That engineer was so happy because he just implemented a bug fix. Believe it or not, the bug fix was that curtain. On sunny days in Stockholm, in the middle of the summer, our matrix factorization jobs that we ran to do things like create a related artist used to cause the cluster overheat. And when you put the curtain up, it allowed the matrix factorization jobs to run and everything to work again. Anyway, for the first 5 to 10 years, growing our machine learning capabilities was primarily about growing our data capabilities and our ability to process data at scale and to build unique data sets that were relevant to our growing machine learning ambitions. Eventually, as more and more frameworks came into play and machine learning grew in popularity, we started to see more teams use machine learning in the product. We started to see all different kinds of combinations of tools being used to accomplish similar outcomes. While this was an awesome movement, it actually skyrocketed the tech debt for teams using machine learning. It made it incredibly difficult to move across teams and confusing when starting new projects. Around 2017, we decided to create an infrastructure team focused on machine learning. Our core mission was to increase ML productivity, and we did that by building common tooling and establishing standards for machine learning development at Spotify. We've had a pretty interesting past since then. A few of our developments that ended up being pretty much dead ends, and some lucky bets that saved us a lot of development time. While we don't have time to walk you through the journey in detail, and I will shout out that we have a team teardown panel tomorrow that you can check out for more information about what we're talking about here. We do want to talk about what we built, and I'm going to switch it over to Aman to fill you in on some of those details.
Awesome. Thanks, Josh. Hey, everyone. My name is Aman, and I'm a product manager on the ML platform working on Jukebox, our feature management framework. I'm going to be taking you through our platform and giving you an overview of the components and their functions. We'll also be diving a bit deeper into the feature workflow and how Jukebox fits in. So kicking things off, let's zoom out and take a look at what our goals for the platform are. First off, we wanted to build a platform for active ML use cases. We do this by working closely with partners such as Google, as well as open source and internal platforms to build a foundation to support ML practitioners and unlock their productivity. Next, we wanted to reduce the cost to maintain ML applications. We centralized common components of the ML workflow by taking the pain of our customers and owning common infrastructure. In doing so, we introduce quality and standards that help with long-term maintainability of ML systems. Next, we aim to democratize machine learning. We do this by enabling the use of ML in teams without ML engineers by leveraging the knowledge of our experts, facilitating the sharing of information and investing in educational efforts. ML practitioners are our primary customer, but as Josh will talk about later, our goals as a platform team is for customers to be able to apply ML across the company. Lastly, we want to support state-of-the-art ML. By continually investing in emerging areas and supporting our internal research groups, we strive to create a best-in-class experience for our customers to keep Spotify ahead of the game when it comes to machine learning in the media space. With that, let's jump into an overview of the platform. At a high level, the ML workflow at Spotify can be broken down into discrete and iterative steps, from data analysis and exploration all the way to model serving. Our platform is intended to cover the breadth of user journeys mapped here, with individual components spanning part of, or in some cases, the entire workflow. One thing to note is that the boundaries of these components often overlap with each other. Our intention here was to create an experience that allowed users to move fluidly between components for parts of their workflows and create a cohesive experience across the platform. Let's jump into each of these components in a little bit more detail. First off, we have Jukebox, our internal feature store product. Jukebox is an ecosystem of libraries that allows users to easily reuse components in their own workflow for feature management at time of model training and serving. I'll be diving a little bit deeper into the Jukebox workflow in just a little bit. Next up, we have Spotify Kubeflow, or SKF. SKF is a managed platform to build, iterate on, and deploy ML workflows via Kubeflow pipelines. Kubeflow platform offers tooling that allows users to more easily take an ML project from idea to production by reducing the friction in experimentation. Prior to SKF, some teams reported taking weeks to go from idea to production, with issues around scaling, training, and managing resources, coordinating daily retraining, and evaluating their models over time. SKF offers an SDK and CLI on top of Kubeflow platform's tooling to easily define, compile, and run complete end-to-end ML pipelines at scale that interface with our existing data infrastructure. Going back to our goals, this allows us to reduce teams owning infrastructure around model training so that they can focus on actually doing ML. This leads us to Salem. Salem is a Spotify-wide platform for serving ML models online. It does this in 3 simple steps. If a user gives Salem a model, it will return a backend service. When a user sends features to the service, Salem uses those features to make predictions. When a user updates their model, Salem handles updating the service. Before Salem, there was no standard path when it came to model serving and deployment. Teams were left to figure out how to create a backend service to host their ML model and then figure out how to redeploy whenever the model is retrained, amongst a ton of other MLOps tasks. This process wasted countless hours of ML engineering time. Salem aims to automate all of this so that now users just call an API with the path of their model in GCS, and Salem will deploy it for them. Next, we have ML Home, which offers a centralized user interface to our tools and applications. We built ML Home because we realized that even with standard tools, users still have to switch between multiple interfaces to complete their ML workflows. Prior to ML Home, most teams were actually relying on spreadsheets to track results between runs and different features. ML Home provides a centralized place to store project information and explore other ML projects. It also contains a built-in feature repo that ML practitioners can use to explore and identify relevant features, as well as an offline evaluation tool that allows teams to quickly review trained models and pick the best performing model. Next, we have Clio. Coming back to our guiding principles, Clio helps support our next generation media processing use cases through a collection of ML application libraries. One new use case for Clio is Sing Along, which dynamically separates the vocals of a track and enables a user to sing along to a song. This feature is currently deployed in Japan and some other markets in Asia, and I've heard it's pretty popular. Around mid-2020, we actually announced that we open sourced Clio and have been getting great reception so far. So be sure to check it out if media processing is part of your domain of expertise. The piece that ties these components together is ML Engagements, which is actually a team focused on ML education initiatives and outreach within Spotify. Early on in our journey, our team received feedback that ML practitioners often didn't know how to get started with our platform or which tools would fit their use case best. They were used to doing ML at other companies, which may be different from how we do ML at Spotify. Our engagement team leads user research sessions, courses on how to do ML at Spotify, and provides best practices on how and when to use certain products. We've seen great successes with this approach to bring on more internal customers to our platform and shortcut the feedback cycle from idea to experiment. If you have any questions about any of these components, we'll also be doing team teardowns, as Josh mentioned, where we will be able to discuss these components in more depth. With that overview, let's dive a little bit deeper into Jukebox. Prior to Jukebox, there was no centralized platform to explore and share features across teams. Furthermore, we know from feedback that joining features from different sources for training and then serving them for inference is a tedious task. That's where Jukebox comes in. Jukebox is an ecosystem of libraries that allows users to easily reuse components in their own workflow for feature management. We aim to reduce the time it takes for users to discover, share, and implement features for model training and survey. We do this by simplifying feature management, from experimentation all the way to online serving. I think the best way to illustrate how these components come together is to use a real-world example. So let's say we'd like to create a model that predicts how much we prefer a given artist and uses this prediction to rank the order of songs in a playlist. This model could tell us, for example, do we like the Beatles more than the Rolling Stones? Had to use this image for copyright purposes. The goal of this model is to support all users and artists within the platform. If done in batch, this would require a pretty inefficient number of predictions, roughly around 300 million users and 10 million artist pairs. We can make this online prediction for the user-artist pair available at request time as a service. This makes it easier and more scalable for teams within Spotify to build more personalization into their applications using the output of this model as an input to other models. For instance, an in-app messaging feature. Some example features we might use are acoustic features to determine the type of music a user likes and compare that with acoustic features of the tracks of that artist. These features may be updated from a daily or hourly batch job or dynamically provided by another service at request time. So walking through the workflow, the starting point is the feature registry, which is the single source of truth for features. Users first create and register features, then combine features to train models offline, and later combine the same features to make predictions online. Users can explore the registry via our feature gallery UI component in ML Home, where feature consumers can search, discover, and understand features they might consider reusing in their model. Features that are available for sharing and reuse are also visible here. Registered features, no matter how they are stored under the hood, whether they are Avro or TF-example on GCS or BigQuery, can be retrieved by a collector component, which selects and joins features from upstream data endpoints with TF record as the output. When joined with labels, these features can be used to create a training set. The loader then ingests TF records from GCS into Bigtable using a specified schema. For example, we accept TF examples and protobuf for input and provide TF examples for output. Bigtable is the storage layer for all of these features, and each team is responsible for their own Bigtable cluster. And we provide the tooling to easily set up a feature store instance. The reader is a Java library that makes features available at scale for low latency read from an online service. It also reads data from Bigtable to be used as an input to the model by the TF records produced by the previous stage. The reader looks up the latest partition for each table and provides optional in-memory caching for the feature. At the end of model training, the feature transformation is saved as part of the model graph. This dramatically simplifies model management and guarantees the same feature transformation used in training will also be applied to serving, so there's no data skew. Through our internal metadata service, we associate features with their corresponding trained model at serving time and can begin making predictions of how much you like a given artist. The logs produced at time of serving can then be stored, registered, and used for further model training. And that's a quick overview of Jukebox. If you have any questions about any of the components I went over today, or about Jukebox in general, feel free to post them in the chat and we'll answer them after this. I'll hand it back over to Josh to give a quick overview of some of our learnings along the way.
So thanks, Aman. Yeah, that was a great overview of what we've built. And while we built our platform organically, there were a few important lessons that we picked up during our development that have been pretty important to us. We thought they might be worth sharing with you all too if you're building out your own machine learning platform. The first lesson is that the most impactful projects that we built have been a result of collaborations between infrastructure teams and teams that are actually doing machine learning themselves. Working directly with our use cases and getting the quick feedback about what are the most important features for us to build and prioritize has really sped up our development, from the building of a Kubeflow infrastructure to the feature and model serving tooling that Aman just talked about. The second important lesson that we've learned is that we've needed to be super opinionated to build a better machine learning experience. This is really difficult because there are so many awesome tools and frameworks machine learning teams could use. But early on, we realized that supporting everything was impossible. And it was actually a worse experience when you were onboarding because all the potential choices for a project. Being opinionated allowed us to create a more powerful and more cohesive product experience that makes machine learning products more predictable with less custom codes, lower rate of technical debt, and less of the confusion when you're starting out a new project. The final lesson that we've learned is that we need to make, as a platform team, we need to make some difficult trade-offs. Our first difficult trade-off was to build a platform solely for machine learning engineers and solely for the production machine learning use case, which in our situation were models that needed to handle the scale of those 300 million users using the Spotify app. Focusing on this allowed us to reduce the maintenance burden of our ML teams and free them up for more machine learning development iterations and to free them up to build out new machine learning projects. But of course, it came at a cost. It meant less of a focus on non-ML engineers and less of a focus on the earlier model prototyping phases and exploration phases. In 2021, one of our biggest goals is to change that and to be more about expanding the breadth of our platform offering. We want to support all different paths of the machine learning development cycle and improve our tooling in the areas that we've previously underinvested on. We want to grow our platform beyond a tool used mainly for machine learning experts that understand the full end-to-end workflow and start to build functionality so that additional roles, particularly data scientists at Spotify, can really speed up the development process. And a couple of our other focus areas that we are working on in 2021 that we wanted to shout out are directly related to that platform expansion, like the quick model prototyping that addresses really the earliest phase of the machine learning workflow. It's all about speeding up that feedback loop and allowing our machine learning practitioners to write more ideas quicker and build better products. Related to those two related to that is two additional themes. MLOps is about improving the guardrails and solidifying the best practices for machine learning. Training models rapidly and deploying often, we want to get on the road to a continuous learning cycle powered by frequent model trainings and frequent model deployments. Our machine learning experimentation theme is all about ensuring we're able to deploy new approaches fast, with tight integrations to our A/B testing framework system at Spotify and tight integrations with the appropriate online metrics tracking tooling. Next, you see our feature marketplace focus, which is a continuation of what Aman talked about and something we think is extremely valuable to machine learning teams, but especially those teams starting out on the machine learning journeys that can leverage existing features. Finally, we want to make Spotify one of the best places to work at ML as an ML engineer that cares about ethics. We do this by building fairness and bias tools into our default platform and making those tools frictionless to use. So that was a quick overview of what we've built in the last few years, why, and what we've learned along the way. Of course, as we grow as a platform, our ambitions to grow as a team increase too. And I'm happy to say we're still hiring quite a few folks for 2021. If you're interested, please go to spotifyjobs.com and apply. So thanks so much for your attention. We're now going to switch over to questions, and we're really excited to hear what you have to say. Thanks.
All righty, Josh and Aman, welcome up. Let's jump into Q&A. We've got some interesting ones coming in via the Q&A panel, as well as the chat. Let's start with one that is asking about just the amount of time that it took to put all this together. Like, what's the roadmap been for you, and how has it evolved?
Yeah, I guess I'll start off answering that. Again, thanks for having us at the conference. It's been a joy to present what we've been building. So we started our ML platform group around 2017 is when we started to invest in that area. We realized it was bigger than just like the data infrastructure team that was originally starting to build some individual tools for some of our critical pipelines to like Discover Weekly, Release Radar, some of our personalization stuff that we had to get a little bit more organized. So we've been growing the team since then, pretty organically. A lot of what we presented today, like Jukebox and Salem, has been mostly built over the last year and a half. So I'd say that's about the time frame that we're looking at.
Awesome. And you mentioned Clio as an open source product. Are there other tools that you've open sourced?
Yeah, I can take this one. From a platform perspective, Clio is the latest product that we've open sourced. We also just recently announced that we've open sourced Backstage, which is actually the platform that we've built ML Home on as well. So that's more of a component management tool. I'm not sure, Josh, if you have any more.
We've open sourced a few of our Kubeflow components for building clusters. And there's a few other things that we actually used in a previous platform. So we open sourced this tool called Featran, which is a Scala-based feature production library. We also open sourced our previous model serving framework called Zoltar. But those aren't super active, but they are in our Spotify GitHub repo.
Awesome. Question about centralized model governance. Do you have a centralized model governance system in place for managing risk and other things? If so, what does it entail? Are there, if not, how do you implement governance guardrails that, keep an eye out for issues like bias and related issues?
Yeah, so we don't have anything centralized. Not exactly sure sort of what that would look like or what that would mean. What we do is we have it, the governance is mostly aligned with the team. So a lot of the fairness and bias stuff that we talk about, what we try to do is to push that down to the team to encourage them to use these tools to understand sort of what is going on in their model, to control for any sort of negative stereotypes that we're putting in. And we do have sort of a centralized process, like a check mark sort of set up to ensure people are building their machine learning models responsibly.
All right, great. How many folks are working on building the platform?
I guess I should know this. I would say it's around 30, in between something like 30 and 40. To some degree, it's either bigger or smaller than that. We work with a lot of the ML teams that are actually building out models. So one quarter we might have 40 people working on this together. If we're pulling in a team building out some ML, I would say our core platform it's in the upper 20s, I think.
Okay. And this is maybe a specific one, but hopefully you can answer it. Are SKF and Salem using GPUs for training and inference? And if you can, what types of latency thresholds do you have in place to meet your SLAs?
Yeah, so we do use GPUs occasionally. We especially use GPUs with some audio processing that we do. I've seen a lot more GPU usage on sort of the data prep side of things and building out features. Not so much on the model training yet, although we do have the capabilities via the tools we work with Google Cloud, and not so much on the serving side yet. As far as latencies, we go down to as ballpark under 100 milliseconds for some of our models that we have user facing. It's lower than that, but I think that's just to give you some idea. It's under 100 milliseconds for a lot of our model serving.
Great. Let's maybe slip one more question in. Many teams build their own ML infra. When onboarding teams, do you have issues where the platform struggle to keep up with what the teams already had? If so, how do you deal with onboarding them? In fact, actually, this is something that we're going to talk about actually in quite a lot of depth in the team teardown tomorrow. So unless you've got something quick to toss in, we'll maybe hold that question for then.
Yeah. It'd be great to see what they say about that tomorrow.
There's another related one about kind of technical PM, and we'll cover that one on the team teardown as well. I think that is time. Josh and Aman, thanks so much for joining us. It was a great presentation, and really appreciate you coming on for the Q&A as well.
Cheers. Thanks, Sam.
Thank you.